Hello, and welcome to a SearchStorage.com presentation, Securing Sensitive Information, How Tape Encryption Can Help Safeguard Data. This presentation is being brought to you by the LTO Program. For more information on the LTO Program, you can click on their logo in the lower portion of your screen. My name is Tim Wynn, and I'm the moderator for today's presentation. Joining me today is Ray Lucchese, President of Silverton Consulting. Before we begin the presentation, I'd like to bring up a polling question to the audience. The first polling question is, I am planning to implement tape encryption in 6 months, 12 months, 2 years, or do not plan to implement. If you could please answer that question. During this presentation, the slides will be pushed to your screen automatically. If you have any questions throughout the presentation, you can type them in the Ask a Question area located on the right side of your viewing console, and they will be addressed at the end of the presentation. If you have any difficulty reading or viewing the slides, there is an enlarged slide button that you can click on, which is located just below the slides. And if you experience any technical difficulties with this presentation, there is a help link that you can click on the lower right-hand corner of your screen. Before we turn things over to Ray, I'd like to push the second polling question out to the audience. The second polling question is, which are the biggest pain points for implementing encryption? Please check all that applies. Cost, speed, time required to encrypt data, performance impact, key management, defining standards, policies for compliance, and complexity. And with that said, I'd now like to turn things over to Ray to begin the presentation.
Hello, my name is Ray Lucchese, and I am President of Silverton Consulting, a strategy, storage, and systems services company based in the United States of America. Thank you for taking the time today to discuss securing sensitive information and our tape data. Today we plan to discuss data security. Why does IT need to secure data? What is the cost of a data security breach? What exactly is cryptography and how it can be used to secure data? Where IT shops can perform data encryption? What is key management and how it is used to secure data? And finally, we plan to describe how one user secured their data using LTO-4 data encryption. So, why does IT need to secure data? Legislation and regulations throughout the world are requiring companies to secure customer data as part of normal business practice. For example, in the USA, we have the Sarbanes-Oxley, Graham-Leach-Bliley USA Patriot Acts and others, which require companies to maintain corporate and customer data security. In the European Union, they have the EU Data Protection Act. In Italy, the Authority for IT Public Administration. And in Germany, the Principles of Data Access and Auditing of Digital Documentation. And finally, in Japan, they have the Electronic Ledger Storage Law. In the U.S., over 245 million data records have been breached since 2005, according to the Privacy Rights Organization. For example, in February 2005, one bank lost backup tapes containing over 1 million Social Security numbers. In May 2006, a government agency's stolen laptop and drive contained 28 million Social Security numbers. In January 2007, a rather large retailer's unauthorized intrusions breached 47 million credit and debit card numbers. Nonetheless, data is still being lost. Just within the past month or so, another major retailer breached millions of credit and debit card numbers, and it continues. Even for those industry sectors not operating under strict compliance jurisdiction, the cost of a security breach can be substantial in both monetary and non-monetary terms. For example, an average data security breach notification costs approximately $50 per record lost, and these costs are increasing. And one event for a major retailer cost over $130 million in notification costs and financial remedies. In addition, there are significant non-monetary costs as well, including embarrassment through bad publicity, lost current customers, and lost new and future business. One little-known fact is that most notification legislation specifically excludes encrypted data because such data cannot be read without the associated encryption keys. As such, cryptography is one way to minimize the risk of data security loss and customer record exposure. Cryptography can render data unreadable to anyone except authorized personnel who have the data keys. Strong cryptography algorithms exist for encryption and decryption, such as the Advanced Encryption Standard using Gallus Counter Mode, or AES-GCM. And most standard encryption algorithms can support various key lengths, such as 128, 192, and 256-bit keys. And of course, the longer, the better and more secure. In general, there are two types of data cryptography: symmetric and asymmetric key cryptography. Symmetric key encryption uses a single key known to both the encryptor and the decryptor. Symmetric key encryption is relatively fast, but the shared key must be known to both parties. In the graphic on this slide, Alice wants to send a message in secret to Bob. She uses the encryption/decryption key to render this plain text into unreadable ciphertext and sends this over to Bob. Bob decrypts the ciphertext back into plain text for reading by using the shared secret key. Asymmetric key cryptography uses two associated keys, one a public encryption key and the other an associated private decryption key. As such, there is no shared key to transmit, and asymmetric key cryptography can often be used to transmit key data for symmetric key cryptography. In the graphic on this slide, Alice once again wants to send a message to Bob in secret. But this time, Alice uses Bob's public encryption key to render the plain text into ciphertext and sends this to Bob. Bob takes his private decryption key and decrypts the message to read it. The key factor here is that no one other than Bob needs to know his private decryption key. Data can be encrypted at a number of points during its processing. Data can be encrypted when it's transmitted from place to place using something called data-in-flight encryption, securing data during transmission. Data-in-flight encryption is often used to protect data that needs to be transmitted over open, unprotected links, such as the Internet. Data-in-flight encryption protects data only while it's in transit. For example, on the Internet, the URL prefix changes from HTTP to HTTPS to signal that the data is being encrypted. It is important to realize that data-in-flight encrypts data before being sent and decrypts data after it's received, and the key is only used during that transition and is discarded thereafter. So the key is not permanent. Data at rest encryption. As another alternative, data can be encrypted where it's stored, such as data at rest encryption. The advantage with data at rest encryption is that the data is potentially protected forever, and it's only decrypted when necessary. Data at rest encryption is often used for data that needs to be stored and retained for long periods of time. It is important to realize that data at rest encryption is permanent, as data stays encrypted as long as it's stored, and thus data at rest encrypts data when it's written, and data decrypts data after it's read. Another key important point is that the keys have to be retained as long as the data needs to be read. There are many different locations where data at rest encryption could be supplied within a data center. For example, software encryption is a facility available to many operating systems and takes place on the host or application server. Appliance encryption can be purchased that takes place within a standalone appliance dedicated to encryption that is placed somewhere in the data path between the host and the storage media. Switch encryption features can be installed that takes place within a SAN switch that already resides in the data path. Subsystem encryption features can be enabled that takes place within the storage subsystem prior to storing or retrieving the data from a device. Device or drive encryption options are available that take place on the storage device closest to the actual media itself. For all of these approaches to data at rest encryption, a key manager supplies crucial and critical functionality and will be discussed in detail later. Each point where data at rest encryption could take place in the data center has its advantages and disadvantages. For example, server software encryption is cheap and readily available, but it consumes scarce host resources. Appliance encryption is a potential data path bottleneck and may represent an availability concern, but it does offload scarce host server cycles. Switch encryption may be difficult to configure and expensive, but performs well and has extremely high availability. Subsystem encryption is similar to switch encryption in both positives as well as negatives. And drive and/or device encryption is highly scalable and redundant while supporting high availability and high performance. As noted previously, key management systems are critical to any data at rest encryption implementation, and as such, control the keys for any data encryption needs within the data center. Key managers create an initial set of secure keys to be used for any data encryption. The key manager stores these keys in a key store and can replicate these keys to any associated key manager for high availability and redundancy. A key manager supplies the appropriate keys whenever called upon for encrypting or decrypting data. Key managers can be implemented in a number of ways. They can be implemented as a separate hardware appliance or as a software service running on standard servers. And key stores are effectively repositories for keys managed by the key manager. Key management systems supply keys for data encryption and can be hardware appliances or secure software running on a single or clustered server for high availability and disaster recovery. In the graphic on this slide, key managers are involved in transporting keys to the tape hardware for data encryption/decryption, transporting keys to any disaster recovery site needing access to encrypted data, backing up key store data for restoration in the event of a catastrophe, and that's about it. It's important to realize that tape data is protected while being transported and residing in any off-site storage facility. Key management systems are straightforward and are responsible for key sharing to share encrypted data with a business partner or disaster recovery site. In this case, keys must be shared. Initiating a new set of keys, the more keys the better, as we've discussed before. Rotating keys supplied for data encryption so as to maintain maximum security, and key destruction for data shredding. And as such, destroying keys will securely erase any data that's encrypted with them. Key management disaster recovery options. Any disaster recovery Any disaster recovery for encrypted data must include a means to provide an appropriate key manager and the associated data encryption keys to the disaster recovery site. Some of the ways key management systems share keys include replicated key stores, where the key store data itself is replicated and available at the remote site, and as such, easily accessible when needed. Key store backups. With a key store backup, the key store can be restored and brought online at the disaster recovery site whenever required, and/or remote clustering. This is a form of replicated key stores where both the primary and secondary site are actively creating encrypted data, and both sites share a clustered key store. Just want to go back to this prior slide, see if I missed anything. So the keys here for key management. In order to share tape data that has been encrypted, you have to share the keys. Key management manage the actual count of the number of keys. They also provide keys to any time data encryption is required, so key rotation is one aspect of key management. And if you want to actually shred the data, that is, destroy the data, make it unreadable, you can also you can do that by destroying the keys. So sorry about that. I'll move ahead 2 slides back to where I'm at. Tape encryption overview. Tape encryption is a standards-based approach to provide tape device data at rest encryption. New SCSI commands such as security protocol out and security protocol in provide a means to interrogate the encryption status of a tape volume and a means to provide the key for encrypting or decrypting tape data. In the graphic on this slide, server data to be encrypted is passed through a data protection application. The data protection application or backup communicates with the tape transport through standard SCSI commands to provide key information to the transport. The transport encrypts or decrypts the data inline, and what resides in the tape cartridge is unreadable cipher text. There are really two ways to control encryption in the data center. Application Managed Encryption, or AME, is controlled by an application such as a backup package. The application is in charge of making a request to the key manager for the new encryption keys or decryption keys for old tape data that's been encrypted. Note that not all backup applications support AME, but some of the more popular enterprise class ones do, and more are supporting it every day. With AME, or Application Managed Encryption, the key data is sent to the drives over the data path using SCSI commands previously discussed, such as SP in or SP out, or security protocol in and out. However, all encrypted tape data must be created and or accessed through the application that manages tape data encryption. The other choice for managing encryption in the data center is called Library Managed Encryption. As an alternative to AME, Library Managed Encryption, or LME, is managed by tape libraries. Here, the tape library is responsible for requesting new keys for data encryption or old keys to decrypt tape data. LME uses the library to tape interface to transmit the key information to the tape drive. LME also supports multiple tape device encryption services and supports any application requesting encrypted tape data residing in the library. LTO-4 LME overview. With LTO-4 encryption, using Library Managed Encryption, the library obtains a key for tape encryption/decryption from the key manager and provides it to the tape transport when requested. Backup administrators do not need to get involved in this activity at all. Keys can be transported to the library over secured Ethernet links. The library to tape transport interface is also over a secured channel within the confines of a library and uses standard automation or library to tape device interfaces to provide key data to the transports encrypting or decrypting tape data. In the graphic on this slide, the application makes a request for a cartridge mount as part of a list of cartridges that the tape library knows should get encrypted. The library then requests an encryption key from the key management software and supplies it to the tape transport. This process occurs outside of the backup or any application and is therefore transparent to backup applications, helping to make LME a relatively simple process to implement and manage. Some LTO-4 frequently asked questions include, does LTO-4 encryption impact tape performance? In most cases, the impact is less than 1% and is invisible. How many encryption keys should I use? Typically, we recommend 256 or more keys should be used in rotation to maximize security. How long should I maintain the keys? You need to maintain the keys as long as the encrypted tape data needs to be accessed. When the tape data no longer needs to be accessed, the keys can be destroyed, and by doing so, we'll shred the data on those tapes. Some key management system frequently asked questions include, which encryption style is supported by the key manager? Library Managed Encryption is the most popular, and ensure your vendor solution supports it. What sort of key stores are supported? A wide variety of key store standards are emerging over time. Ensure your vendor's key management services supports these standards to ensure future interoperability. Does the key manager support high availability? There are many varied approaches to high availability. One popular solution is the cluster key managers. But in any case, key management systems are critical data center infrastructure and as such need to become highly available. Does the key manager support network key transfers? Transferring keys across existing data center IP networks can be an inexpensive solution and, depending on your key manager, also a secure one. Let's talk a little bit about an LTO-4 encryption case study. Providence Health Services is a network of hospitals and other health service providers in 5 states in the northwest corner of the United States of America. Providence Health has 6 data centers and implemented LTO-4 tape device encryption in all of them within days of having the equipment installed. Providence also implemented LTO-4 encryption without the need of any external services, just by referring to shipped documentation. As a health provider, Providence operates under HIPAA or HIPAA regulations and is subject to periodic audits to verify the patient data is secured throughout its enterprise. Providence chose LTO-4 tape encryption to secure patient data taken off-site. Providence used library-managed encryption with a clustered enterprise key manager services and LTO-4 tape drive encryption for their off-site data encryption. Providence was able to get LTO-4 encryption up and running in their data centers very quickly after installation of the hardware. Matt Kigata, data storage engineer at Providence Health, said there was no visible performance impact from implementing LTO-4 encryption. Summary. In today's highly regulated environment, data security breach costs are significant, and one sure way to minimize this is to encrypt your data. Data at rest encryption can be used to protect data that is stored and as such is subject to loss. Of the many means of providing data at rest encryption, the most scalable, highly available, and high-performing option is device encryption. Tape device encryption is best for data stored on tape. It can help ensure your data is always protected wherever the tape media resides. So for more information, please contact myself, Ray Lucchese, at the phone or email listed on this slide. And now I will turn it back over to Tim for some questions. Tim?
Thank you for your presentation, Ray. I'd like to take this time to remind everybody that you are participating in a searchstorage.com presentation, Securing Sensitive Information, How Tape Encryption Can Help Safeguard Data, which is being brought to you by the LTO Group. If you would like more information on the LTO Program, you can click on their logo, which is located in the lower portion of your screen. We are now moving on to the live question and answer portion of today's presentation, and encourage you to ask your questions in the Ask a Question area that is located on the right side of your presentation screen. We will respond to as many as time allows. Before we begin the question and answer session, I'd like to push the polling results out. For the first question, am I planning to implement tape encryption? 40% said they would be pushing it within 6 months. 26.6% will be implementing it in 12 months. 20% will be implementing it in 2 years, and 13% do not plan to implement any tape encryption. And for the second polling question, which are the biggest pain points for implementing encryption? The largest pain point was key management at 62.5%, followed by defining standards and policies for compliance at 43.7%. Both cost and complexity came in at 37.5%, followed by speed and the time required to encrypt data, and finally, performance impact was at 25%. Thank you for participating in this poll. So let's begin with the question and answer portion. Ray, it looks like our first question is, we use tape for backup and move tapes off-site, but have not had a tape lost or stolen. Do you think it's necessary for us to invest in LTO-4 drives and media anyway?
Good question, Tim. The issue is that the fact that you haven't had a tape lost or stolen to date doesn't mean you won't have one in the near future, possibly tomorrow. The fact that LTO-4 tape drives and media support encryption is a key consideration. And tape backup and off-site tapes can be lost. even though yours haven't been. So you should encrypt data. So I think that's it. I should mention, I'm sorry I didn't mention, but there is a white paper associated with this presentation that can be found on the LTO program website at ultrium.com. So if there's any further, any questions that we don't get to today, perhaps you can read the white paper to pick up some answers from that.
Thank you, Ray. Before I ask the next question, I'd like to, again, remind the audience that you could ask a question in the Ask a Question area located on the right side of your viewing console. Our next question is, you mentioned that the user, Providence Health, implemented LTO-4 encryption in about 1 day, and that it was a fairly simple process. Did they hire services to help them do the install?
No, Mac indicated that all they did was actually follow the documentation available from the tape transport company and the key management system that they purchased and library manager, and they were able to implement it without any outside services whatsoever. Next question.
Okay, our next question is, early in the presentation you recommended 256 tapes. How was this number derived?
I'm sorry if I misstated. It's actually 256 keys, not 256 tapes. So in a key manager system, typically you can identify the number of keys to initiate and or create. It could certainly be a number like 32 or 64,000. Some people have, and I would suggest at least 256 keys for your tapes. How many tapes you have is based on your own requirements for saving backups and that sort of thing.
Okay, thank you. Our next question is, I am at the DR site and need to quickly restore the encrypted data. How do I prepare for that?
Well, again, in the case of encrypted data, that keys that associated with that encrypted data have to be available at the disaster recovery site. There are a couple of ways to do that. The key manager itself could have clustered key services which replicate the key store. You could have a key store backup on a non-encrypted tape that you restore at the disaster recovery site. Or you could actually have the key in your hand somehow to be able to, on a USB stick or something like that, to restore the data. But effectively, that key has to be available at the disaster recovery site in order to provide reading of the data.
Okay, thank you. We have been fielding questions about the slide presentation. The slide for the on-demand version, the slides will be available in the slide presentation. Again, if you'd like to ask a question, please type your question in the Ask a Question area on the lower right-hand corner of your screen. And if there are no more questions, Ray, would you like to make any closing remarks in this presentation?
Other than the fact, I think tape encryption is a relatively straightforward process nowadays. In times past, it was much more difficult. The key management services available for many of the vendors in the TPC and otherwise are relatively straightforward to implement and to purchase. The LTO-4 tape drives now come with encryption all available on all the tape drives coming out of the TPC group. So that's relatively straightforward. Obviously, you have to have those keys available at the disaster recovery site. I noticed in the poll that one of the more critical questions or critical concerns was key management. It doesn't have to be that critical anymore. The key management systems exist. You can rotate the keys. You can create 256 keys. You do have to store them. You do have to back them up. There's no question that all that still has to happen. But key management can be relatively straightforward these days. And Mac at Providence Health is an example of being able to do this without any help whatsoever. Okay, Tim?
Okay, thank you, Ray. That concludes today's presentation, Securing Sensitive Information, How Tape Encryption Can Help You Safeguard Data. If you would like more information on today's material, an archive version will be made available on our searchstorage.com webcast library. I would like to thank Ray Lucchese for taking the time to be part of today's presentation. And I'd also like to thank the LTO group for sponsoring this event. And as always, I'd like to thank you all for taking the time to join us today. This is Tim Wynn wishing you all a great day.